No matter what study type you use, you have to be very careful of bias. So a study will have bias if it systematically produces results that misrepresent a population. So an unbiased sample is a sample which each member of a population is equally likely to be chosen, so it's random, okay, is representative of the population as a whole, which means we're not just looking at, for example, if I was looking at all the students at Science Hill, I don't want to just look at the football players or just the band kids. I want to make sure I'm looking at every different population in the school. Anybody in the school could be equally chosen there. And it has to be large enough that the results can be generalized, meaning I can't just pick two students in the school and make a general assumption about the entire school based on those two students. I need a big enough sample to make it actually bias free. Okay, so these are things that we look for when we are trying to create some sort of study. Now, in order to select a sample that is likely to be representative of the population, you have to choose members of the sample using randomness. So a simple random sample takes a small random portion of the entire population to represent the entire data set where each member has an equal probability of being chosen. Now, for example, I could have 250 employees. I could put all their names in a hat and I could select 25 out of them, 25 of them. That would be a random sample. Nobody has any different chance of getting it as long as they're all on the same size paper, the same type of paper, and they're all mixed in, okay? Now, there are different types of sampling methods that we can use to try to keep things bias-free. So the first one is called a stratified sampling. And this is when a population is divided into groups with similar characteristics, and a sample is randomly chosen from each group. Okay, so for example, we might take a population and group them according to their age, and then choose a random sample from each group based on age. At Science Hill, maybe I can group everybody by interest or by after-school activity, and then I can make sure and choose somebody from each group. Okay, so that's a stratified sampling. Cluster sampling is when a population is divided into convenient clusters and entire clusters are chosen at random as the sample. So for example, a number of hospitals around the country were randomly chosen. Then at those hospitals, we select all the nurses. Okay, so this is called a cluster sampling because we're looking at the hospitals and then we're taking those clusters of hospitals, we're looking at the nurses in those specific hospitals, okay? Now, a systematic sampling, this is the one that's probably the most used at kind of the level we're at. This is when you choose subjects that are is when you start with one member chosen at random, then you use a rule, such as every third member of the population to select members of the sample. So for example, if I was wanting to choose students randomly, I might start with a randomly chosen ID number. Maybe I had every student's ID number written down. I'm going to start with one randomly, and then every fifth student's ID number I'm going to choose, and that student's going to be asked to fill out a survey. This could also be done like if you were at the mall and somebody's asking a survey. They might look for, every fifth person that walks by me, I'm going to ask them to fill out my survey, or every 10th person, or every 30, or whatever. Okay, so you're actually asking a specific number rule to be able to systematically select random people. Now, the other two, convenience sampling and self-selected sampling, these two are rarely bias-free. Okay, so convenient sampling is only choosing subjects that are in close proximity or easy to get to. So for example, a city wants to know what percent of people in the city own a dog or cat. A city worker might go door to door in the neighborhood that's close to City Hall to ask people about their pets. That may not be representative of the entire city because maybe where City Hall is, only certain people live there. So that one is not going to be as bias free as our other previous sampling measures. The same is true of self-selected sampling. Okay, this is when you use a sample made up of volunteers. So like, for example, a retailer puts feedback cards at the front of its store. They get responses from 22% of their customers, but think about who's going to fill out those surveys. It's either people that are unhappy and or they want their opinions to be known. Not everybody in the whole population is going to fill out those feedback cards. So these two right here, we have to be careful of, because they, again, are rarely bias free. But they are convenient, hence the convenience sampling, and they are often easy to get people to volunteer. So like when you see a survey at the bottom of a like at McDonald's, you get a survey at the, hey, fill out this survey, you'll get a free Big Mac or whatever. They're trying to entice you to do the survey. Who's going to fill it out? Well, the person who wants the Big Mac or the person that has something to complain about is most likely going to fill it out. Okay. Now, we can also insert bias unintentionally through wording of questions. So like if we're trying to do a sample, we might say, oh, you like this school, right? That unintentionally puts bias into the questioning. Okay, we can also have problem if we do the wrong time and location. So for example, if you were going to do a phone survey and you called everybody at noon, well, you're not going to get a representative of the whole population, because around noontime, most people are at work. So you're only going to get people that are retired or don't have jobs, or maybe young people that would be home at noon and not working. Okay, so we have to be careful with bias when we're doing our different survey types. Okay, so this example isn't in your notes, but this is a really good example. So in this situation, we have 100 people that are surveyed on a sunny afternoon on Saturday, and 65% of the people said they were happy. And then 100 people were surveyed on Monday morning on their way to work, and only 35% people said they were happy. So this right here is an example of bias. They looked at it on a Saturday when people maybe aren't at work, they're in the park, it's a beautiful day out. Of course they're going to be happier than Monday morning going into work. Okay, so because of the time and the manner in which they conducted this survey, they had biased results.